Hi, let me show you the exact hardware setup used in this demo. Both displays you see here are running from a single STM32H7 and are reacting to each other in real time. Let's start from the center. Here we have a 7-inch Riverdi display with an integrated STM32H7 microcontroller. It runs the application firmware, handles the main user interface, and controls everything else you'll see in this demo. This is also the only programmable device in the setup. All firmware is flashed to this STM32 using ST-Link over SWD, which you can see connected here. On the right side, we have a second 7-inch Riverdi display, this time based on the EVE graphics controller. This display does not run any application code of its own. It acts purely as a graphics coprocessor. The power is supplied to the STM display directly. The connection between these two displays is RiBUS. It also provides power to the slave display. This is the complete hardware setup from this video. If you want to take a closer look at the displays used, you'll find all the links in the description below. Now that we've seen the hardware, let's move on to the software. The complete project used in this demo is available on Riverdi's GitHub repository. You can either clone the repository or download it as a zip archive. Once the cloning is complete, let's open the Cube IDE. In the project directory, you need to find the Cube folder and copy its path, so later you can paste it into the project wizard in the IDE. It should be in the main directory. From the main menu, choose File, then Import, and select existing projects into Workspace. Point the wizard to the unpacked project directory and complete the import. After that, you should see the full project structure, including the TouchGFX application and the EVE4 integration code. Let's also take a quick look at the TouchGFX designer. This project already contains a complete TouchGFX user interface for the master display. At this stage, there is no need to modify anything. This step is only to confirm that the TouchGFX project is correctly integrated. Now let's return to the Cube. Now that the project is validated, let's take a closer look at its structure. This walkthrough is important not only to understand how the demo works, but also to show where you would adapt the project to your own hardware configuration. This is where the MCU startup, clock configuration, and peripheral initialization happen. The main function follows the standard STM Cube structure. It's the first place you would modify when adapting the project to a different display. Next, let's look at the TouchGFX part of the project. This directory contains the TouchGFX application used for the master display. Here you program all the logic and functions that you want to be used from pre-generated buttons, sliders, and other widgets from GUI. As you can see here, there are functions that change the color state of the screen when you press one of those 4 buttons that are generated in Touch. If you want to learn more, check one of our previous videos, where we show how to set up a simple project and where all the logic is hidden, while using TouchGFX. The UI layout you see here matches exactly what is rendered on the STM32 driven display. TouchGFX itself does not control system clocks, but it relies on a correctly configured LTDC, memory subsystem, and DMA bandwidth. Next, let's look at the EVE4 related code. This module contains the low-level EVE driver. It handles SPI communication, register access, and display list support. Here, you will find the EVE initialization sequence, including power-up timing and basic configuration. If you are using a different EVE display size, a different resolution, or a different EVE4 panel variant, this is where the display-specific parameters are configured. The EVE display runs in its own FreeRTOS task. This task builds display lists, processes touch input from the EVE panel, and updates the shared application state based on user interaction. This separation allows the EVE display to operate independently from TouchGFX, while still reacting to the same application logic. This project structure is intentionally simple but scalable. TouchGFX handles the master UI and remains isolated. EVE rendering is encapsulated in its own driver and task. Application logic is centralized in a shared state module. Let's get quickly through the demo. On the top you can see STM32H7 display. On the bottom there is an EVE. In the top right corner of STM you can see the current color of EVE. Whenever we accept the change on the slave, master updates the slave's color preview. When we decline the change, nothing updates neither on the master or on the slave, as it should be. We just showcase the communication between two different displays using SPI. If you want to learn more about building projects with STM display or BridgeTech EVE display, please refer to our previous videos that you can see on the screen now.